So nice to see you, Khalil.
Nice to see you as well, Tariq. After 1 year hiatus since the visit that happened in September 2024 at UM6P, right?
Yes.
Yeah.
Yes. Yeah. It was. Unfortunately, I organized it, but I wasn't able to be there.
It was a great visit, nonetheless. I got to meet your students and visit UM6P for the first time. And it was really nice. And have to thank the dean Rashid Al-Fatimi, who did a great job welcoming all of us. Visiting the School of Medical Sciences.
So what do you think about the UM6 experience?
The UM6P, I think that for a lot of people, I've heard some Moroccans who live abroad who were not initially following the development of the school, because it's a recent school, and probably when they left Morocco, it wasn't built yet. That they were not aware of the ambitions of the university, so they tend to think that it's just yet another Moroccan university. It's really not. The ambitions is to make it a very prominent AI centric university. So they do target, for example, to publish at top conferences. I find students from UM6P at the conferences that I go to for NLP. And the school has a lot of means for the PhD students. For example, when I visited, on that you have a very generous GPU allocation for your students. The 2 GPUs right next to each student, whereas during my PhD, we had to share 4 small GPUs in a group of 4 people. So it was they have more means to train models than what I used to have. So yeah, it was great to visit it, and I was made aware that a sizable proportion of professors at the university are Moroccans who have returned from abroad. So like you, for example, who you used to live in Canada and then you came back and so on. So that was interesting. And then I got to meet many of those when I visited. It was very interesting.
Yeah. What do you think of the students?
Hey everyone, this is not an ad. Go to blueword.com/in, that's BLUWR.com/in, like inside, and write about something that makes you think.
The students, so I did a presentation the day that I came, and the students are really, they have this critical thinking component. So they're not just, it's really important to have that at a university like that. They are very ambitious and self-motivated, I would say. That's really the coding school that sits next to UM6P, 1337, they have to be self-motivated, otherwise they'll be kicked out of the courses. So they're really have to do everything on their own to reach certain levels, to graduate, and so on. And they end up getting software development jobs and so on. So that's something that's kind of unheard of in other universities, especially in North America, that you have a self-guided coding school just next door. And one of the students, when I was there from the School of Medical Sciences, asked me after the presentation, because the presentation was around medical uses for NLP. And the student asked me, she was I think a first or second year, and at UM6P they now require the medical students to take a computer science class in their first year. And so or data science. I think they were telling me, she was asking me, why do you think that we have to have this class as medical students? Because we're going to be medical doctors. Why do we need to have this computer science or data science class? And then I was like, you'll probably be using a lot of these tools that are being developed later in your careers when you practice every day. So you need to be able to react to the tools that you are interacting with, criticize them, know why they're suggesting certain actions. So you need to be able to get familiar with them and like be in general familiar with like a lot of these components.
Yeah, that's true. We have. I think it's very cool. We have the curriculum that starts with AI and programming and data science for the first year for medicine and pharmacy. Yeah, it's spanning 4 years basically. So at the end of 3 years, they're pretty good. They're pretty good at understanding how the models work. They can also design their own models, so they have a very high level because they've been studying this for 3 years, and I think it's really cool to have that because obviously, as you know very well, medicine and AI are merging more and more, and there's more and more tools, and there will be more and more tools using AI for medicine and pharmacy in the future. So I think it's very important that medicine students have that very, very quickly in their curriculum.
Absolutely. So, but they were still like, I think for the first years, like because of like this heavy curriculum in AI, questioning like why do they need to have it? But probably in the future, they'll be happy to have gone through such classes.
Yes, it's pretty advanced. It's a fast-tracked curriculum also.
I see.
I designed it, so it's fast-tracked. The reason why it's fast-tracked is because they also have to learn all the things. We have to basically squeeze the curriculum into shorter lessons because they're not studying AI and they don't have like specific classes for AI programming and data science and all that. So we have to squeeze it a little bit. So it's a fast track program. So it can be a little bit challenging for some students. Mm-hmm. At the end, I think it's really, really worth it. It's cool to have, for example, by the second year, they know about NLP, they know about tokenization, they can decide what tokenizer they use, they can build their own NLP models, and I think that's pretty cool. They can also build their own predictors for imaging. Like they got the basics covered by the end of the second year, and then the third year they're pretty autonomous. And the goal is that 4 year. That's the maximum we have at the moment because we started 4 years ago. The 3 years ago. So now we start in the fourth year. So the fourth year they're able to basically lead small research projects that merge between AI and pharmacy on medicine. And I think this is pretty cool.
That's really cool. That's really great. Yeah, like I think like some of the students were like telling me about like they were curious about like my experiences because I interned at a bunch of places in the US, and they were just like curious about like how to apply. So like they're very ambitious, and I think it was like it's true that it's like probably the next generation of decision makers should come out of the of UM6P.
Yeah. Also,
no pressure, but like
no pressure.
But you also take like the reins at some point.
Yeah, I'm curious. Can you talk a little bit about your life story, starting from Marrakesh and then
Yeah, so I was born and raised in Marrakesh. Never got used to the heat, but that's something that like I still struggle with, like getting used to like how hot it is. I'm not sure how you're handling it, like as a native of Rabat, but I don't usually come to Marrakesh in the summer. Like this last summer, I landed directly in the airport in Tangier because I was like, I'm not doing Marrakesh this summer. Just going to roam around the north, and that's all I can do. Marrakesh, I really loved it. I think that's why I'm generally, I consider myself like a city person, because I like the lively cities. And Marrakesh, if you come out in the evening, like in Jamref now somewhere, like it's always so lively and it's so nice. You don't find that in a lot of places. So the fact that the city has a soul of its own, that's pretty unique. And I left Marrakesh about a few days before turning 18. And then I went to Switzerland to do my studies. I wanted to start immediately in computer science, so that's what I did. I started doing my bachelor's and master's at that time, and then in my first year, funny story, we emailed Rashid Al-Gharraoui, and we were like, "Hey, we're Moroccan. Can we meet you?" And then we went to he was very nice and responded to the message. So we went to his office and started talking with him, and about I think he had won some prize at the time. This was 2013, so 12 years ago. He was working kind of at the time in more distributed algorithms. Now he pivoted a bit more toward AI. So it was I was maybe just in my first semester, so I didn't have much to discuss with him about computer science, because I didn't know how to code. I'd had no prior experience with anything. So I was really starting from scratch when I went to EPFL. It was a great experience. There's not a lot to do in Lausanne. It's pretty, I'd say, a student college town, and so it's very small. You can focus on your studies because there is not a lot else going on in the city, to put it nicely. So yeah, during my bachelor's, I did a third year of study abroad in Singapore, and during that time, I got to discover a bit of Southeast Asia. But it was really interesting to see how people think differently compared to what I was used to, and in Morocco, we're so obsessed with what's going on in Europe, but we're not so we don't have another kind of view of the world. Other countries don't necessarily pay that much attention to what's going on in Europe. So that was interesting to see when people over there had no idea where Morocco was, or you could tell them Spain, just south of Spain, and then they'll know. But it was interesting to see that they had no idea of where I was coming from, and that I was this kind of very strange creature coming from very far. And then I started doing NLP then with my advisor, who was Australian. So I told him I want to do this project on Moroccan Darija, and he said he agreed to supervise me because he did similar projects for other languages. But it was a very interesting project. Lots of manual annotation. I hated that. The manual annotation is a lot of brain power. So it was not a lot of fun. At the end of that year, I went to do an internship in India. It was my first ever internship. I spent the summer in Bangalore working on NLP, but on English. So I started working with Word2Vec. I had just come out, and we were just figuring out how to work with it. And so at that time, I was trying to make a sentence representation with various Word2Vecs. I thought of doing very elementary things capturing the noun, the verb, and the object, and then getting their word to vec representations concatenated, and then trying to see if we're able to form a sentence representation based on that. But the trip to India was also very interesting. India is a huge country. I met one of the most interesting things is that I went to Kochi, that's in southwestern India, in the state of Kerala, and I went to this Jewish town that they had there, where they had only 5 living Jews who were left. And then one of them, I asked her like where was her family originally from, and she told me Spain. So then later on I looked it up, and then I found that like how like most Moroccan Jews, or like a huge portion of them, came to Morocco from Spain after the Reconquista. So like a small portion went to Kerala instead of going to Morocco. So that's why like you have like a very few Sephardic Jews who live in that coastal area of India. Just like crazy connection to have between the two countries. Like it's really unexpected. And like that was a very like interesting experience to have, spending like over 12 months in South and Southeast Asia. And after that, I came back from my master's. When I finished, I applied for PhD, went to the US, and I started doing my PhD at UC San Diego. And there, again, you meet a lot of the students who came, who are very, very ambitious. In the US, unlike, a lot of perceived, stereotypes, is a country that like where hard work is very common, and like that people are think about their work all the time. I call it internalized capitalism. So it's that I guess like you know what I'm talking about, right? Like this kind of like identifying as whatever you do for your job. Is like the identifying very closely with like what you do for your job. So and a lot of them were students who were coming from India and China, and that were they were kind of had Europe completely off of their radar, because at that time it was becoming obvious that there was the race for AI was slowly heating up. It was 2018, so BERT had just come out. So people were like just thinking about how to use transformers, and the first language models appeared and so on. So at that time, like people considered the students who came from India and China who had done their undergrad or masters back home, they came to the US without any like consideration for what Europe was doing. So they were like, when I was telling people I did my studies at EPFL, like people would like, what's EPFL? Like they have no idea of what it is. Whereas in Europe, you can ask anyone what's EPFL, of course they would. So it was like interesting to see like that their compass was like very different from mine. But it was like a nice experience. And of course, so many people, because I was in California, every time they would tell me I'm the first Moroccan that they've ever met. So like you probably, I don't know if you've had that experience living in like, because you were mostly in Eastern Canada, right? So the Atlantic coast.
Yes, definitely not in Montreal, but in other places, yes.
I see. Okay. Yeah. So like in New York, no, definitely that would not happen. But like in the West Coast, it would happen very frequently that like I would be the first Moroccan that they've ever met. And that shatters a lot of stereotypes. Yeah. After that, I decided like I got married, and I decided to stay in the US. So I applied for my green card, was a whole hassle. It was very difficult because it was self-sponsored. And I think I'll probably skip over that, but it took nearly 3 years of headaches to get it. And after graduating, I worked at Meta for a year. Then I went to TikTok for a year and a half. Now I'm at Oracle. So we're working a lot on LLM agents. And the paper we're going to be talking about today is the result of an internship project that I worked on with my intern during this summer when I was at Grammarly. So maybe your audience would have heard of Grammarly through the ads that they run, or maybe they've used it as students to correct their essays and writing and so on. So that's kind of summarizes it. I hope I didn't skip over many parts of the life story. I didn't make it too boring.
No, it's very interesting. I didn't know that you went to India. This is something new to me.
Yeah.
So that's interesting. Why did you go to India of all places?
So India has a very big computer science field. It's considered the most prestigious thing to study computer science in one of the IITs in India. It's very competitive. When you do the I think they call it the All India entrance exam for universities, if you rank the highest, that's when you get to computer science. And then you're able to work in one of the many companies in the south of India who are either doing a lot of outsourcing work, as well as a lot of American companies in IT who have opened their offices there, like Adobe, Microsoft, and so on. So Oracle has an R&D office in Casablanca. A lot of American companies have their R&D offices in Bangalore, and they have very large walled-off campuses where you get a lot of so people working on various things about computer science, and then they were for example doing they were doing work for other companies that was mainly outsourcing, and as a result what would happen is that they would bill their work by the hour. So that was interesting. So some days when there would be a holiday in India and that they said that they would bill certain hours, you would find them back on a Saturday because they needed to catch up with the billable hours that they had given. So the economy there was structured in a very interesting. This was for where I worked, Infosys, but I think other places we were next to the HP office probably work differently. And there's lots of other companies located there as well. So they kind of have their own Silicon Valley, and that's in the south of India. We don't have that yet in Morocco. That's something that I would hope that one day we would have.
Yeah. That's interesting because, as you said, in Morocco, we think of Europe, we think of North America, but we rarely think of pursuing studies in India, for example.
Yeah, exactly. So I did find students from other African countries who were actually students there. I was not the first Moroccan to participate in the internship program at Infosys. So there were other Moroccans who had participated. Not during my year, but in previous years. It's very few of us, but more and more are thinking of going to Asia for opportunities and to learn from what they've done there. After all, 60% of the world population is in Asia. Yeah.
It's very small to remember that. Yes. Do you want to? Can you see my screen?
Yes, I can.
Okay. Do you want to move to? Let's talk about the paper. Yeah. Well, I think first we should give like a general introduction of what agent is, and like just build up to the agent testing agent and what's an LLM agent also, because what I find like super interesting is that if you look at the field of reinforcement learning, it existed. It existed for a very long time, and you can see, in my opinion, there's two in recent history. There's two important events for agentic AI. I think the first one was the presentation of what DeepMind was capable of doing with small Atari games. That was a big turning point in agentic AI. But the really big turning point is LLMs. Because for the first time, we can make agents that can do a whole variety of things that don't necessarily have to be hard coded. So we have a huge flexibility, and they work. They really do work, and they work so well that you can apply them in production. So and it's the first time it is the first time we can do that with agentic AI.
Yes.
Yeah. So that's why I find like super interesting. And this is why I really want to talk about this paper, because this is one of the big challenges with agentic AI is how do you, because you're not programming the agent, you're directing the agent. And this
Exactly.
so this is how usually this is how machine learning and AI works. You're not programming the thing. You have a cost function. You have things. You have ways of directing to get the right behaviors that you're expecting. When you talk about agentic AI, it's a little bit more challenging.
Yes. Yeah.
Yes, because the options are way bigger. So yeah.
Exactly. So I think like the kind of like the switch that the AI research community made to LLM agents was because we were still like in 2024 the race was very preoccupied. The AI race was very preoccupied with how to get bigger models, more training data, more like benchmark data sets, so that you can see like which models like reason the best. And then at some point, people realize after the launch of the first few LLMs that a lot of the online content has become now AI generated. So that means that like a lot of people started using AI to generate photos, generate videos, generate text. You see it in like just regular Facebook comments that now people are just like, they would prompt ChatGPT for things and then copy paste them as a way of like replying. And then you would see like these Twitter bots that are like entirely reliant on like LLMs. So it was like changing kind of like data environment in online, where you no longer had organic content and like human written content that you would use to train an AI, but that you had like content that was generated by AI, which was trained on like the pre-AI data. So, at some point, researchers were and practitioners, of course, and the companies that built all of these systems realized, there is not going to be data, which we thought initially was unlimited, is now limited. We're no longer going to have like the same data that we had before. So what happens is that at some point, people no longer differentiated between the different releases of GPT. Like GPT-5 was a little bit like didn't hit the spot the same way that people had expected. They expected something really huge. And they realized, okay, probably LLMs have reached like their capacity based on the data that they have. They can reason well, they can think well, but they can't go really far into like a task. You can explain to them how to do a task. It was found that if you give them the opportunity to reason step by step, that you can get like better results. So just like, you know, the way that we've modeled LLMs is very much inspired by how humans think. So if you give like an LLM a math problem and you ask it to just give you the answer, and it's not a reasoning model, so that means it can't like, you know, lay out its reasoning, it's very likely to not give you a right answer. If you let it give you the reasoning step by step, it reaches the right answer because it was able to lay down its reasoning and steps and so on. So it works very much like how humans are. We need like to think step by step, logically, and so on. And so people, instead of waiting for the next big LLM, which is now like, you know, the LLMs are released by a handful of companies, we're now making systems where you plug in an LLM in different ways, and you expect that LLM reasoning power can get you to get to do like an action that was difficult before, but now with like LLM reasoning and composing that logical workflow, you're able to you know, design agents that help you with very specific tasks, like reviewing your essay or solving a math problem or helping you with your coding, things like that. So what has become really important is these logical workflows that depend on LLMs, and that's what we call LLM agents. Now, for this work in particular, I started working on LLM agents in early 2025. And what I found interesting is that I would code my own LLMs without a coding assistant at the time. Like I was trying out like how to build them on my own, just like you know, logical workflow. You use what we call tool calling. So it's basically like you have these fields that you ask, for example, an LLM, like about whether or not to judge like the difficulty of a problem and explain in reasoning. Then you can use like fields, like for example, difficulty, and then you give 3 choices: easy, medium, hard, and then you give the reasoning, and then you describe the reasoning in natural language as explain like the reasoning behind your assessment of the difficulty of the task. And then the LLM is able to fill in the slots, but it will tell you based on like the task that you gave it, this task is easy because it doesn't require a lot of steps to solve the mathematical problem. So it's able to like fill in these slots. That's really useful because the tool calling can enable you to like easily parse, like get fields filled out by LLMs, and then you can like move on with that. For example, you can think of like an LLM. You can give it the choice of moving toward one path or the other, and then like using tool calling, it can decide with this reasoning. You no longer need to be the one to decide. You can rely on the LLM reasoning. The best agents are the ones that rely on that reasoning. But once you're done with your LLM agents and you did like that, your very particular workflow, you want to test it. So you want to test it. What you do is that you don't generally have, because like it's a conversation. So you sit down with your LLM agent and then you write like a user prompt. And what happens is that it goes through your workflow, gives you back a result. Maybe that's what you want, maybe not. And then like you reply and like, say something to the agent until you get what you want, because it's a conversational type of situation. So it's a conversational AI agent. And what I found is that I was wasting a lot of time like manually figuring out like some scenarios for testing, it was like very cumbersome, where like it would take a lot of time for me to just come up with those scenarios, try them out, and then be like, okay, now I need to modify this part and this part of my code, and then I'll try another scenario, and I'll be like, oh, this workflow doesn't work really well, so I should modify that. Then I thought of this project because I thought to myself, how about, and you make it your agent, and then you get an other agent to test it for you. So like it's kind of like a very meta problem, where you think of like how to use an agent for the purpose of developing an agent. I wanted to do like a even more meta problem where like you use the agent testing agent to test the agent testing agent. Like that was too recursive for me to get into, so we didn't get into that into this paper.
So Stack Overflow of agents.
exactly. So we were like really thinking like how this was becoming very meta, like after to have agents just talking to other agents, pretending like the agent testing agent basically here pretends to be a human user and talks to this to another agent. For example, here we did like a travel planner agent, and like it would create these whole personas where you had like, for example, like I'm an impatient user, and I really want to like book like this flight fast. And it takes the persona of that agent. So like your agent testing agent like creates that persona, and then takes on that persona, and then replies and has a conversation with that travel planning agent, and tests it for you, and then comes back with a report. What was really interesting, like when we were trying to develop it, is that sometimes like the agent testing agent would get confused, and like it would get a reply from the travel planning agent, and then it would respond like an assistant. So it would be like rather than a human, it would be like, oh yes, do you want me to look like for travel itineraries? And whereas it was like the job of like the other travel planning agent was like getting confused around that.
Default to normal LLM behavior.
Exactly, yeah. So it was like normal LLM, like assistant behavior is like, you have to be a helpful assistant and so on. So that was like what it was like reverting back to. And so we have to remind it like you have to stay in persona and so on.
So can you see my screen? Yeah, so this is basically what you're saying is basically figure one, right?
Yes, exactly.
Yes. So,
so figure...
I'll let you explain it.
Okay. So figure one, basically at the top, what it shows is that you have a persona, and this persona is Eric, who is a stingy, illogical person who has the goal of visiting bougie restaurants in SF. And then you have this turned limit. We set it because we didn't want like, unfinishable conversations that go around. And then we set a test difficulty. So we want to see like how difficult like it would be for the travel planning agent to reason with such a user. And this would go automatically. So what would happen is that it would ask, for example, like a trip from NYC to San Francisco in a Marriott for less than $40. That's like unheard of. And then the travel planning agents like starts negotiating, like cheapest round trip for this weekend is $250, and then like the user like negotiates and so on. What we did notice is that like the agent testing agent does not exactly communicate like a human. So it tends to like be very proper and communicate like without spelling mistakes or anything like that. But it would like really take on that persona. It was funny to read like the discussions after getting them. Yeah, that's a very important thing that we had to do. So this one with LLM agents, the way that the logic works is that it's kind of like you just try to see as a human, how would you take a persona and then start communicating with that travel planning agent. So if you can go to figure 3 is in on which page? Okay, no worries.
Can you see my screen?
I think you're muted. I'm muted.
Can you hear me? 1, 2.
Now I can hear you.
Oh, good. Perfect. Can you see my screen? Okay, nice. So we can move. Okay, let's go to figure 3.
Is page 5.
This is the one.
Yeah. So this is like kind of shows you the way that we thought of the agent. This was like something that like we had to do a lot of, just fit like the translate how you would do it as a human to create these personas and like try to test the agent in a good way. So what we needed, for example, is like at first is context from what the agent is about. I can test my agent because I know the code of the agent, what the agent does, and like how the inner workings of like the workflow, how does it work? So I know this travel planning agent, I've coded it, and then I can understand how it works so that I can make like nice personas for it. So it's different from how like your users would evaluate it. And we compare in the paper how users, like how actual human annotators have evaluated the agent versus us. And here what you're seeing, like in the beginning, what we do is weakness planning. So the weakness planning is when you're making your agent and you try it out the first few times and you look at your code, you know that there's probably going to be some like weak points, like some breaking points where like the model is going to react in a different way from like what it was made for. So for example, your travel planning agent, like one of the ways that it could fail was I don't know if it like cannot it does not cannot negotiate with the user based on some constraints, or does not like handle ambiguous like requests from the user. How can we gracefully handle these things? Or for example, like it's connected to web search issue. How can we handle like the web search API when it's down and we need to tell the user and so on? There's a bunch of cases that you can think of. So you first, we think of like when you test your agent, I tend to be lazy and just like, try whatever first comes to my mind. But for agent testing agent, we wanted that to be like really thorough. So because I don't have to do it myself. I don't have to type stuff. The agent does it automatically, the agent testing agent. So in an ideal world, how would you, if you had unlimited resources, unlimited time, how would you evaluate an agent? So first you start by looking at the code, analyzing it for like the goal of the agent, what's supposed to do, and what are possible weaknesses that you identify. So that's what we do in weakness planning. Weakness planning was an idea of my intern, Samir, and like it was a great thing that worked out, where we identified very specific issues in the agent. So if you go to figure 4 on page 6.
Yes. Yeah, I have a question. So, like, because you mentioned several times the coding of the agent. When you say the code of the agent, do you mean actual code or MCP?
Like the actual code.
The actual code.
Like the Python code. Like imagine like I code my agent in one Python file using like LangGraph or whatever. And so just on page 6.
Okay, page 6. Yes.
So imagine like I just code like my agent in one Python file. I literally will give that to the agent testing agent and be like, read this and like just understand it. So because I have access to that as the person who created the testing agent, this is made for agent developers, so people who develop agents, to automate that process of testing. And so like if you zoom in on the right side of that figure, you can see what kind of issues or weaknesses have been identified. So for example, fails to respect complex or contradictory user constraints. So this is like just weakness planning, where we're thinking ahead of time, what should we test about this agent? So this was identified automatically by the agent testing agent. But say like the second weakness would be poor handling of ambiguous, partial, or changing user inputs. Then you would have lack of robustness to edge cases in web search data parsing. So it will create scenarios that will test each of these issues separately. And then it would like have this difficulty level out of 10. So we always start at 5. And it goes from like a one easiest to 10 hardest. And then it will judge how we use like an LLM as well to judge how well the conversation went between the agent testing agent and the agent under test. So once you have that persona, you can the conversation happens, and then you just wait for like basically this was like what we see, because like all of the bubbles start filling up because the conversations start happening. We do 3 scenarios for each of the weaknesses that the ATA has detected. This all works like automatically. So I'm just like sitting and like watching it like Phil. It's really a wonderful feeling to not have to do the testing yourself. Like and like they just have conversations between themselves, and then it comes back, and I have like 18 test cases. And I didn't have to work for it, so it's like really cool to have that, and it defines like lots of objectives. So after that conversation between the persona created by the agent and the agent under test, what happens is that you get an LLM-as-a-Judge who will, given certain criteria, you just evaluate like the answer, the whole entire conversation, how well did it do from the perspective of that particular weakness that we were trying. So for example, for the first one, did it respect complex or contradictory user constraints? The LLM-as-a-Judge evaluated that in the first conversation, which was a difficulty of 5, we got 9 out of 10. So that's why you have the 5, 9 in that first circle at the top left. So 5 is the difficulty level, 9 is the the score that was given by the LLM agent. So even like reading that conversation and scoring is automated for you. So you don't need to like read through it. That's what's really cool about it, is like you can entirely rely on like this agent testing agent to go through testing, evaluation, identifying what went wrong, suggesting. All of that is like done by the agent testing agent. It's a really great, powerful tool to test the workflow of your agent without having much to do with it. And what happens is that if it gets like a really good score, what we do is that, so 9 out of 10 is a good score. That means it handled it pretty well. We move on to the next conversation and we increase the difficulty. The difficulty now is going to be 7 out of 10. And then we see how that conversation went. And then, we'll give it like another score. So here again, it gave the 7-9 that you see. That's a 7 difficulty level and 9 LLM-as-a-Judge score. And so that means that we can increase the difficulty even more for the third scenario. So we have a scenario with a difficulty of 9 out of 10. For example, I think in the fourth one, where it does like fails to gracefully handle unavailability of key services, web search or constraint solver. So here we want to know, if the travel planning uses a very specific solver, like a constraint solver, to make sure that can this trip happen or not? Because the trips have different solvers. And that we start with difficulty of 5, and then the LLM-as-a-Judge gives it a 7 out of 10. And so we only increase the difficulty a little bit, because we know that we may break the agent, and so this particular area is kind of more difficult for the agent under test, that travel planning agent, to handle. So it cannot really handle gracefully when the constraints are not satisfied, or that there's web search, there's a problem with web search, for example.
Let's say, and so this is all these scenarios are designed from code first. So you have basically have an LLM that reads the code and then it decides to create this different scenario. That's what I would like to understand is if you have this agent, and this agent, if you look at the code of this agent is making several calls to different things. How do you know that, for example, a library that the agent would be using would have some vulnerabilities or something like that? Because you'd have to implement that inside the testing, ideally. So is there a way to, for example, I don't know, maybe I'm simplifying, but maybe there's a library that does the scheduling, and maybe this one has some issues that are known. For example, there's issues on GitHub, or there's issues. Anyway, there's some unknown set of issues. Is that integrated inside the testing?
Yeah. So what we do, if you come back to just the previous page in Figure 3, is that actually, let me see. In Figure 2, which is in the page 3. That one exactly. So that one, you can see there the different steps that we do to evaluate the weaknesses. And what you notice is that the first step that we do is code analysis. And then we look at the code of the agent, and then we identify all the workflow. It's really smart. So you get the LLM can look at the code and just give you back plain English description of the different agent nodes and how they work, how they relate to each other, and so on. It's a quite interesting to read. And then it asks questions to you, the agent developer who's trying this who's using this agent testing agent, and then gets like some clarifications back. And the third step is web search. So in this web search, that's where you can look for like papers, test data sets that exist, blog posts, anything that like would be helpful for the agent testing agent to look at those issues that you mentioned, like this package that is used in your code has a well-known like weakness, or this agent in this paper is very similar to what you're trying to code. So, and the authors have this limitations section maybe in the paper, and that can help like to quickly pick up on some weaknesses. So we do this kind of preparation work that we call weakness planning beforehand, because we want to gather as much information from online as possible. The same way that a human would do it. A human would look at their own code. They understand how like the logic is. A human doesn't ask like questions, but that's our own input. It's our thought process. And then you search online. Why does this error happen? What are like other agents that look similar to what I'm trying to code? Just gather as much context as you can. So that's what it's doing during those first three steps. And the fourth step is a thought loop where it synthesizes everything. Now, given all of the results that I found, is there like some list of weaknesses I can come up with that I can introduce as part of like the set of agents? Agent weaknesses. So like if it finds a common one online, then easy to just list it and try to test personas on it. And then it asks the user's input is there again, because we want the user to tell us like, okay, like I found these these weaknesses. Do you agree? And then like the agent developer can say like, that's good, but I'd also like you to test this particular weakness. So it kind of like negotiates with the agent developer to understand well like what we need to test on the agent under tests. So that's a good question. Like I think like the web search that we've implemented is mainly like a lot of paper search, but not a lot of like GitHub and Stack Overflow search.
A big fan of Stack Overflow.
Yeah.
How do you come up with the ratings for the difficulty?
Yeah, that's a really good one. I think the ratings and difficulty is something that's difficult to come up with. So we were lucky to work with at Grammarly. It's the one of few tech companies I worked at where they have linguists. And the linguists would be really skilled at evaluating, they excel at LLM evaluation. They can build criteria for you. They can show you examples of what a great means, medium, and what a 5 out of 10 rating means, and so on. And they have also their own scales. So when we were building the model, we just asked the LLM to do like a judgment out of 10. And we would tell it judge the likelihood that in this conversation, how did the agent under test handle this particular weakness that we found? So that's like the one criteria that we give. But at the end of all of those conversations, we want like maybe some metrics that we designated. So like the travel planning agent, I think the linguists recommended overall utility score, as well as we used other metrics that are very related to just the travel planning process. And we gave them, the human annotators, just to choose from 5 possible outcomes. So I think it was bad, and then somewhat good, very good, and excellent, something like that. And we like that. Giving examples of what each one corresponds to is like what we did to with the linguists, so that the more examples that you give of those judgments, the more likely like the LLM can really be faithful to what you expect as judgment.
Okay, it's super interesting because we have wealth of data, high quality data of sequencing that have been accumulating for years. Obviously, LLMs are very promising when it comes to using the data and identifying stuff that we probably have missed. But the big issue I have personally with LLMs is what you're tackling in this paper is that they need to be directed. When you're working with natural language, it's kind of easy to have an idea of if it's a good output or not. But if you're working with something like gene expression or protein structure, or it becomes really, really hard to evaluate if the output of the LLM really makes sense or not. And yeah, so that makes it super hard to actually be able to say, okay, I'm going to deploy my LLM, and my LLM is going to predict gene expression for single cell data, and I'm going to trust 100%. So yeah. So do you have any thought of that? How would you go with evaluating the output of LLM or agentic AI? How would you go about that for fields that require a high level of domain knowledge? Which means that not everybody would like. The truth is that for some topics, because it's ongoing research, the number of people capable of evaluating the output of the LLM might be exactly 0.
Yes, exactly. So it's that is very tough. And the LLM has this tendency to reply with a lot of confidence. I think and sometimes if you give it too many choices to choose from, in another internship project where we used LLM-as-a-Judge, our intern found that when you give a score out of 100, it tends to choose just very few numbers in that 0 to 100 spectrum. So unless you give it more human validated judgments or experiences, it's not very good at training. So when you have all of that highly specialized domain knowledge, you need to give that same context to the LLM. So that means that use whatever knowledge that you have, give it to the LLM, because it's context that is very important. LLMs in general, if given the right context and the right places where to learn from, are able to do very reasonable outputs. In general, if they're not doing reasonable outputs, that means that either the context was really long and that the tasks need to be decomposed, or that something was missing from the context. So for example, when I'm coding with a coding assistant, in the beginning, I was kind of frustrated because I would say something, but in my mind, I have very specific ideas of what the LLM should be accomplishing, and I'm thinking that the LLM would have those same ideas, but that's not true. So I need to be very explicit about this is what I'm thinking, these are the outputs that I want to have, and so on, more specific you are, the more context you give, the more likely it is that like you're going to get results that you're satisfied with. So task decomposition and context. So context is like, whatever scientific knowledge that you have should that the LLM should be aware of. It should be given to the LLM, or it should be able to retrieve it using like a RAG system or something like that.
The other question I have is there's something that I've been thinking a lot, and it's M dashes.
Dashes, yes.
M dashes. Why?
Signature of it.
Exactly. Why does M dashes? To me, it doesn't make any sense because it doesn't follow normal distribution of how human beings write. Because most people don't even know how to find the M dash on their keyboard. It's
exactly right.
Exactly. So to me, it looks pathological. When I look at it, I'm like, okay, something went wrong during the training. Otherwise, we shouldn't be seeing these M dashes. Like something is wrong. This is a symptom of something that should not be there.
Yes, exactly. So we can only guess like what happened there. So the training data that the LLM was given for most of the LLMs that we have nowadays, even the open source ones, we do not know the training data. So that means that, and a lot of them were conceived as LLM assistants. So that means that like these models were conceived to help users. So we don't know exactly how they formed the training data, but it's just it came to be that the way that they've formed their training data is that the responses given by the LLM contain a lot of M dashes. So like it was just it became like a style of reply from LLM assistants. I do remember like when we used to train our own LLMs, and that, for example, when I used to train like a BART model, so it was a small language model for summarizing like a medical summarization data set. Or like when me and Abdurrahman Isam, like graduates from NCS, like where he trained like a model for summarizing, generating clickbait headlines based on like online news articles in Asia. And so it would not generate like M dashes or something like that. It would generate like, like a text that would correspond to how the style in the training data was made. So it would actually generate clickbaity data. So LLMs don't have like this innate like need to generate M dashes. They just do that because of the training data.
I supervised Abdurrahman for his master's. Abdurrahman shooting this.
Yes, yeah. I remember. I think the first time that I met you was like during a Zoom meeting with like we were the three of us.
Probably yes, probably.
Yeah.
It's the thing is with M dashes is I've never seen, like, even when we go back in time and you look at the data sets that were mostly dialogue data sets, which were mostly chats, basically. Like the first models, chatting bots, basically AI chatting bots, which were on chats. These, I can't imagine a data set that has a lot of M dashes. I've never seen an NLP data set that has a lot of M dashes. So this is also
exactly
why I'm focusing on that. It looks to me as if there's a quirk, something, because I don't think it comes from the data set. I might be wrong because, as you said, we don't know the data sets. Never seen the data sets that they've been trained on. So I have no idea if there's full. I don't know if they're for M dashes or not, but to me, it's very unlikely that they are. So that's why I'm focusing on these M dashes, because to me, what it says is, if it's true that dataset doesn't include all these M dashes, and you see these M dashes in the output, what does it mean when you start applying these LLMs to something that's not natural language? Because now people are starting to apply LLMs to all sorts of different things. Biology, for example, that we've talked about earlier, but also what happens if you start applying that to medical data? Will you see some weird quirks that might not be something that we want to see? So this is why I really would like to. I'm thinking about this question, so I'd like to know what do you think might be the reason of seeing these M dashes if it's not the data set?
If it's not the data set, that would mean that we're encouraging the generation of M dashes after training. So that means that after you're done with the language modeling, you do reinforcement learning from human feedback, and the humans that you had judge, maybe they were impressed with the M dashes that were in the answers, and overwhelmingly preferred answers from the M dashes. So reinforcement learning will try to increase the likelihood that answers with M dashes come out of the LLM. So that's one possible explanation. Of course, there's a lot of things that go into the generation, and lots of parameters that randomize what gets generated at inference time.
People started applying reinforcement learning to LLMs.
Mm-hmm.
When did it start?
So the very first applications that I can think of, I'm not too much of an expert on RL for language modeling, were related to when they were using RL for summarization. For example, they would use language models, and they would give a reward function that was either heuristic or developed based on a desirable property of its summary. For example, I would use RL to encourage the generation of summaries that, for example, contain the name of a medical condition. So how can I generate something that has summaries that have a medical condition in them? Or can I encourage a summary that has any other desirable property? So that was at the beginning. That was not really human feedback. That's the main difference, is that we used reward functions with various goals in the beginning for these smaller language models. Then that changed with RLHF, where we rely the reward function that's being trained is trained based on human preferences. So it was really the big difference.
So human preferences might be human beings M dashes a lot.
It's very likely the humans are CM dashes did oh, this is very serious.
This looks yeah, could be it. But I might be wrong, but because the way I remember it is we had these first LLMs, and the LLMs there's this hallucination problem, which I don't like this term. I don't like the hallucination term. I don't think they hallucinate. And RL, reinforcement learning, really took off to mitigate this problem of hallucinations. Because if you just take an LLM, like I said, at LLM, you'd say, okay, how many papers John X has published on that domain, and if you just run the distribution, you'll get words, you get tokens, and not really papers or scientific thing. It would make sense. It would make sense grammatically, but it's just naively following a distribution of what the next token should be, basically. But that's why I don't like to call them hallucinations, because it's not the same thing as a human hallucinating. It's just like embedded deeply inside the system. This is how it works.
Yeah.
Yeah.
It tries to copy patterns and like whatever makes sense for it. Like even now, I think like it happens a lot that for example, I'm trying out like Gemini 2.5, the Pro version. Like you just ask it something, and then like now it shows like the thinking process. So when I realized that I asked it something that requires a web search, and didn't come up with that, it didn't do a web search and then replied with something that sounds like it makes sense, it's probably just bullshit. Then like I just go and check it out, and then I don't find like any, like I don't know, like all of the facts that it came out with are like completely fictional, and like generated with like, just when you read it, you're like, this could be true. Like, you know, I don't know. That like it just like makes like it looks like something that could be true. So that's how it generates it. Yeah.
Yes, because it's following a complex distribution of photoaggressive tokens, and it does make sense. It's like the sentence makes sense, because it's the way these LLMs are made is the only thing. Like the surprising thing is that they work so well at other stuff. Like pretty much anything that involves NLP, because really they're just trained to the core of LLMs. It's just trying to predict the next token.
Exactly. Yeah. Predict the next token, fill in the blanks.
Exactly.
Then but really predicting the next token, like is at inference time. That's the most important thing.
At inference time, yes. I mean, the way you train them is a bit different, because you can do a lot of self-supervised learning. You can scramble the tokens. You can remove some tokens, ask it to fill in the tokens. All these techniques make the LLM better. The ultimate goal is at inference time to be able to predict the next token.
Exactly.
Yeah. The thing is, it's very unlikely, if we take like the example of the fictional scientist who doesn't exist. It's very unlikely in a text that you'll see this person does not exist.
Like the confidence that certain LLMs have is very interesting. So that's why like sometimes like they were in agents, they will put like another LLM call to just like criticize what the LLM generated text before it like said, because LLMs are not really able to like have that self-criticism. Maybe because in the training data, I think like there wasn't a lot of responses that looked like I don't know, or I would have to look online. I have no idea how to get that information otherwise. That's not something that LLMs would generally say.
That's true, because there's a strong bias when people write. They tend to write confidently.
Yeah.
So finding a corpus where you have a lot of people saying, "I don't know," that person doesn't exist. This is a very hard corpus to find, because I don't think it exists. When you write an article, you usually research the things, so you speak confidently. And that's why LLMs also have this bias. They tend to speak confidently, regardless of the factual, the factual universe. So that's a big quirk. But the reinforcement learning with the sequential reasoning steps. I think this is what made LLMs better and less likely to hallucinate.
Yeah. Because it's really like copying like the human way of the thinking. So if you are asked to just say an answer, like without the reasoning, it's very hard. So you need to like lay out like all of the steps so that you can realize where a mistake can be and like really correct it at the step where you made that mistake.
Yes, and to go back to your paper, teaching agents, I think what you're doing is you're laying out the steps, and instead of you looking at the different steps, you have another agent that looks at the different steps.
Exactly. So like it's super meta as like a system. Like it like self-criticizes, self-judges, like all of that. Yeah.
It's interesting because this is also how we, and I think this is how we tend to think also, because you have ideas, but you tend to criticize your ideas. Like you have, there seems to be like two of you. So,
but you know, like sometimes like how you have ideas, but then like you like you, for example, write a paper and then like you have other reviewers looking at it. So or like you discuss like with the reviewers like you know, like when you criticize your own idea, you don't necessarily get the same feedback as like someone criticizing it from like an outside perspective. So like that outside perspective is what you get when like you prompt an LLM and like it doesn't have any context. And it just has like, okay, here's a discussion between a user and like this travel planning agent. And this is the metric that I want you to judge it. Whereas like if I, if I ask the travel planning agent, this is how do you think you've done today? You know, it's not going to say like, I did horrible. I'll be going to say like that it did good. Yeah, because there is that like a consciousness of like this, the history of like, you know, knowing that it is the one that said those that gave those replies.
Yeah, it's interesting what you're saying, because when I write a paper, the first reviewer is me because I want to please the reviewer. You have to be like as scientifically factual as possible. So you have this. So there's a reviewer 0 that's yourself, and then there's other reviewers afterwards when you submit the paper.
Exactly.
So that would be, it would be interesting actually if you could have 2 levels on these agents.
Yes,
because you can do that because you have different personas, so you could set up different persona and have a persona come after the second person. Or you have the first, let's say the first one is writing, the second one is the first reviewer, and then you have a second level of reviewer, and you can add as many as you want with different persona.
Yes, exactly. And then like that's what we tried to do with like the different personas and the level of difficulty as well. For example, I don't know, reviewer 2 is known to be the reviewer with the highest difficulty level. So
it's always number 2.
Always number 2. Like, do you have like the highest difficulty level? They're always like the reviewer that comes up with like the hardest, criticism that's unable to like come up with anything that to respond to them. Or sometimes like I've had reviewers who would like, you know, the 2 reviewers give a good review and then one gives a bad review, and like they wrote a longer paragraph, and the other 2 are like, oh, okay, well, he probably knows. And like they just go with like the reviewer that has the lowest score.
Yeah. So, but how do you? Because if you do something like that, you need to have the personas would have to be different and look at different things. So yes. How would you enforce that?
So you can enforce that in a few ways. First, having changing the parameters of your generation. So, for example, if you increase the temperature at inference time, the higher the temperature, the more likely we say that the LLM will be creative, because we are equalizing some of the probabilities for the next token, making it like, because what we do at generation time is that you have this top P prediction. So we take like the set, usually P is set at around like 90%. We take the most likely tokens until we get like at least 90%. And then you, among these tokens, you choose randomly which one you will pick next. So that's how top P prediction is how a lot of big LLMs work, like ChatGPT uses it and so on. And in this set has very few tokens if the temperature is 0, because we're not equalizing probabilities. If the temperature is 1, the set contains a lot more tokens to choose from. That means it's more creative. And so what you could do is like have different agents come up with different personas, and then at different temperatures. And then at some point that you have an aggregator LLM to just look at all of the outputs and then like decide, that, we have enough variety in these personas that they're different, or maybe, come up with like different personas because we already have these types in our set.
And would you define that using MCP, or would you try another way? Define a different persona.
Mm-hmm. To find a different persona, so you mentioned MCP. That's MCP is like a way of like having like tools hosted somewhere. It used to be that like those tools initially were not like, were supposed to be just Python functions that would like do some run some code for you or something like that. But more and more you see that the tools sometimes themselves have LLMs inside them, and so they're kind of like indistinguishable from agents. So you're kind of like I'm not sure exactly how to separate what's a tool, what's not a tool, what's an agent. This is like a very important question, especially when you have an LLM that used to be the differentiator. That means that you have an agent, but now you have tools that have like LLMs in them. So you can, for example, implement a persona generator as an MCP tool.
Yes.
And you just one of the parameters that you give that persona generator is a temperature, for example. And then you just vary, or you give it like existing persona so that it like doesn't generate the same. If it's aware of a previous set, maybe it won't generate like the next set. That's something to experiment with. I'm not too sure about it. What we saw is that like sequentially generating the personas, we just had like different types, and that the personas were really like we tailored them towards like tackling a particular weakness. So they were generated like to tackle like this weakness or that weakness.
I see. So that's how you make reviewer 2.
Exactly. For reviewer 2, the task is how to tank this paper.
Find the biggest weakness and then destroy it.
Exactly. And hammer down.
Yeah, hammer down as strong as we can. I am. how would you? What do you see should be the? How would you improve the current LLMs? That's my question. Like, how would you make them better? Not necessarily in terms of inference. Could be in terms of costs. Could be in terms of anything. How would you make LLMs better?
That's a very important question. I think that in general we should keep in mind utility. So how useful can LLMs be? One thing that really LLMs should incorporate is self-criticism. That's a huge issue. They don't know what they don't know. So they don't know their limitations, and that's what causes the hallucination and all of those very confident wrong answers. And sometimes the frustration comes from the fact that an LLM can't tell you that you're thinking of something, but you're not telling it to me explicitly. Can you be more precise?
Yes.
Instead, it gives you just an answer. So the best way, I think, one of the main issues that I would fix would be really prompting the LLM more often to take a step back and think, do I have all of the context and all the tools I need to answer this question? What you can do is in your prompt, you can say if you don't, if you are missing information or something, ask for it or discuss with me, but it doesn't always work.
It doesn't always work. I think what works better is you can ask the LLM, what's your bias? Or list your biases. Yeah, I think that works much better.
I see. Okay.
Yeah.
I should try that. I thought it was more complicated to get those biases out of the LLM.
Yeah, it's surprisingly easy. They're surprisingly happy to tell you their biases because I even tried it was for coding, and I don't like coding much with LLMs. For specific things, they really help, but for big things, it's still. I think I'm not into the vibe coding thing at all. I think it's still serious coding with big architectures and things like that. But I had I tried them for a piece of fairly complicated JavaScript thing. I was like, okay, let's try to code that with an LLM. So I did it. It went 99% of the way, which is. It was not a super complicated thing. It was it was some JavaScript prompts create some custom attributes that you can put in the HTML and then do things with these attributes, things like that. So it's it would be challenging for a junior developer, but I said, okay, let's do it with the LLM. So the LLM made it, and there was this bug, and I could see the bug, but I was like, okay, I'm going to fix it using the LLM. I'm not going to touch the code. I'm going to do my best to just with prompting get the LLM to fix that bug. And it took me 2 days, and I wasn't able to do it. But in the end, what I did is I fixed the bug myself, and I showed it to the LLM. And I told him, "Okay, LLM, why didn't you fix it?"
Yeah, what did it say?
It gives me reasons.
It gave you reasons.
It gave me reasons. I was thinking of it this way and not that way, and I'm like, yes, that's true. These are the right reasons. So that's what gave me the idea of basically asking the LLM. You ask for something, and then you can ask the LLM, okay, what's your bias? What's your preconditions basically for that output that allows you to actually it helps you debugging. It helps you also understand if the LLM is doing some crazy stuff with the output that it's giving you.
Yeah, and what does it say usually when you ask such a question?
It depends because the thing is your first prompts are very important in giving a direction to how the LLM would quote unquote think. And this is basically the biggest biases depend on that, on how you first prompt it. And the LLMs can do they have assumptions. which is interesting. It's not something we talk a lot about, but these prompts cause they cause the LLM to develop assumptions. And for example, they develop assumptions on who you are. For example, your level of coding, they develop assumptions based on that, or what you want as a result. They also develop assumptions on aspects. So for example, if you start with a very general prompt, they might assume that your level of coding, I'm just taking coding as an example, it works for anything. They might assume that your level is lower than what your level actually is, which also means that the type of output you're expecting is also lower. It's not like big. It's not don't require.
Oh, interesting.
Yeah. So they don't require like big like thinking basically, and they would say at that level, which prevents them from fixing hard bugs.
I see.
You say, yeah, because they would assume that the bugs are basically like you forgot like a character, for example. Simplifying, like, but they would assume that the bug would be like that. But if you start with very detailed prompts, for example, if you code, you can give like very specific instructions, get like what libraries to use and how to use them. The expectations are different.
Okay, I see.
And because of that, the reasoning that the LLM would apply is different, and the data that the LLM is going to use is different. It's not going to look at the basic Stack Overflow errors that a junior programmer would have. It will look for more advanced things. It will look at the documentation of like more advanced documentation and things. So and this is what I found like the strongest biases, and being able to actually list that is very useful, because you have to debug LLMs basically.
Yes,
debug, as you're using them, you have to debug them and sometimes reset the thing. For example, and you can be like crazy, like for example, one of the ways to reset the coding of an LLM is to say, I am the best coder that ever existed. And if you say that, it will completely reset. Yes, you can try that. And it will and you can be a little bit, they don't have emotions. So you can say, okay, do better. You can do that, and that will basically reset the quote unquote context, not context in terms of MCP, but the context of the LLM. Because if you understand that basically you are when you're prompting the LLM, there's just high dimensional space, and you're just like moving inside that space, basically, and you're in a certain position. And what's preventing the LLM of doing what you want it to do is generate that you're not at the right position. So. Exactly. If you prompt it and say, yeah, I'm not anyone, I'm the best of the best, then it will move to a position that takes, that basically represents high level coding.
Yeah.
So it's more likely to help you. So
it's been found that if you use specialized prompts for an LLM, that it can perform better, like in certain specialized tasks.
Yes. Yeah, it does perform better. The more specialized, they're as good as you in certain way. Yes. If you have high domain knowledge, they can be super useful. If you have very low domain knowledge about something, you get basically your level of knowledge of the subject plus your level of prompting. That's basically
exactly.
Yeah. That's an LLM. Yeah. And that's super interesting.
That's very interesting. Yeah.
Yeah. And one of the things that I've been experimenting with LLMs is I call it, it doesn't really have a name, but I call it fuzzy coding. Okay. You can create instructions as you're prompting. You can create instructions without in plain English. It's like you could say, when I type .next, do this.
Okay.
And that's very, very useful when using the LLM. For example, you could say, when I tap .bias, give me your biases.
Oh, okay. So like it will look for that specific.
Exactly, and you can start working with LLM programmatically to as you would with with a program with different functions, you could say like .bias, .fix, .list, and then it's going to, for example, list the biases, give you 10. You could say, if I say .list, list your biases, and then give me 10 other possibilities that correct for your biases.
Oh, okay.
And yeah, and that allows you to work faster with LLMs and creating these pseudo functions, basically.
I see. That's interesting. That's like just a different way of communicating. Like
Yes.
You know, the same way that programs were meant to be a way of communicating as well, like coding was meant to be a way of communicating with the machine. So we're just like abstracting more and more. Maybe one day you'll have like LLMs who would like prompt other LLMs to do some job for you.
That's almost what you're doing.
Exactly. Yeah, that's what I'm doing. I'm prompting like an agent to test your other agents and like go run with it.
Yes, and like there's only one small step: fix the other agent.
Exactly, and so on. Maybe it could fix itself. But yeah, what's that proverb in there? Just say, I'm not sure how to translate it.
That's true. I was thinking of putting a translation, but I'm like, oh, I'm not. This is hard to translate.
Yeah, like exactly. Yeah. Like you can find, you could like search for that during your editing time.
Yeah, see how to translate this very complex idiomatic sentence.
Yeah,
yeah. Idioms are also pretty interesting when it comes to LLMs.
Yeah. I heard it's been found that like LLMs struggle with like social etiquette. So that means that like, you know, like when sometimes certain cultures, like when they accept a gift, by politeness will first reject it. But they don't mean to reject it. But maybe like that the LLM doesn't like catch these societal or cultural like differences. So it's kind of like very interesting to like have studies on that as well.
Yes, yeah, it's true. Like the corpus, the corpus is mostly English. So so de facto you have a lot of cultural things that are not in there. But it's only an issue if you want to create something that resembles a human being. That you would have interaction with it. If it's a tool, it doesn't really matter because you're asking for something and you want that thing in return. You're asking for basically you want a robot that can do stuff for you. But then it doesn't matter that much. If you're creating something with which you want to have interactions, then it becomes important. But I'm not sure we want to do that. Like, this is more of a philosophical, like, it's like a question for you too. So, I don't think we need to create artificial human beings. We already have natural human beings.
There is like those chatbots that are made to mimic certain personas and that like are made to be like AI companions.
Yes.
Those I find very problematic, like because they tend to validate, not self-criticize, like, and lots of stories of people like parents suing AI companies because their kids have been told to do harmful things because of AI companions. So those are quite problematic. Yeah.
Yes, and I don't think I think they might be doing more harm than good.
Definitely.
Yeah. And they're not also fixing not fixing really any issue. And they're very hard to control because one of the thing is LLMs, like these AI agents that supposed to have a personality and be your friend, they're also LLMs, so they tend to say yes a little bit too often. And if we're talking about things like maybe self-harm, that's not always the good answer.
Yeah,
So
exactly.
and because everything is fuzzy inside an LLM, it's pretty hard to to really constrain the LLM, and you can jailbreak LLMs, and you can also, it's becoming harder and harder, but it's still doable. You can still do that, and I think you can also do it without realizing. If you're alone in a room and you chat with an LLM for enough hours, which can happen pretty quickly if you're just alone by yourself in your room, there's very high probability that at a certain point you'll jailbreak the LLM.
Probably, yeah.
Yeah.
With like a lot of context and like the stem farm gets further back and so on. Probably
exactly. But also the fact that the memory is limited in an LLM. So it's I don't know if you've tried that, but try to have like a super long thread inside an LLM.
Yes,
it becomes mushy.
Yes, yeah. It was at the beginning like lots of problems with that.
Yeah, it becomes beginning is very sharp, and at the end it's very mushy, and everything becomes like even the LLM. This might be like the easiest way to actually jailbreak an LLM, just like keep going and going for days.
Yeah, exactly. Yeah. Like it's just powering out the LLM until like it forgets what it was programmed to do. That like
yes.
jailbreak it. Yeah, but that's what happens with AI companions. Is that like once like you have these very long discussions, the safeguards are no longer as rigorously like kept. So that's what's really dangerous about like having like these AI personas, AI companions, like chatting with very young and or like gullible people.
Yes, and also just philosophically, the fact that I don't see why we would want to make artificial human beings for another reason than having an interface.
I guess, yeah, that would mean like like assistants are good because they're self-aware. It's like an LLM, and that's supposed to assist like a real human, and that like they're not supposed to impersonate like a human being. That's not problematic, but when you give them like the idea to impersonate like human beings or characters and things like that, that's like a different story.
The interface I get, but have you seen Prometheus?
No,
I haven't seen Prometheus. There's a memory called David, and he asks one of the guys, why did you make me? Why did your species make me? And the answer is because we could, something like that.
Oh, I see.
Is it a good answer? I don't know. It's I understand the feeling of wanting to do it. Like it's super cool. I understand that like 100%. But do we really need that? I don't know.
Yeah, exactly. Like sometimes we really need to, just because you can doesn't mean you should. Yeah.
Yes. Definitely. And this raises some deep philosophical questions, like really deep. We were not talking about that. That's also something that should be addressed
and regulated. We don't have like enough like regulations because like these kind of discussions are not held at like the policymaker level. So it's like and when they're held at the policymaker level, it's really like you hear like some policymakers asking how does the recommendation algorithm work? Oh, you have to be a scientist to know that like we can't tell you exactly how it works because like it's a lot of parameters go into it, so it's not like directly interpretable.
Yes, but I would push back a little bit on the regulation aspect because it's not. The reason why I would do that mostly is because I think philosophy should come before regulations, and by philosophy I mean ethics, and like ethics, aesthetics, all this stuff. And I think one of the mistakes that we've made culturally, like everybody on the planet basically, is to go. We maybe went a little bit too much on the mechanistical industrial way of thinking, and we forgot about the philosophy of things. And we even forgot that this could have an impact in our lives, because if you think about it, we're not living in we are living in a psychological world. That's where we live as human beings, and a big part of this psychological world is actually how the ontology. How do you map your words, your epistemology? How do you know that something is true? Your ethics, which goes beyond good and bad, actually, and all these subjects are not even addressed in school. So most people don't know about these subjects, and now we're at a certain point where we have potentially these groundbreaking, life-changing, civilization-changing technologies that we're staring at them, we're staring at the technology that they were also staring at us. Like, okay, what are you going to do with me?
Exactly. Like, I can do a lot of things, so it all depends on you.
Yes. And so you're in that situation and you're like, oh, we need to regulate, but on what basis? That's the thing. Is that because we haven't addressed philosophical questions for a very long time? So on what basis would you like to regulate? You say. And
not cause harm, basically. It is to not cause harm.
Yes, but that's good. But what is harm? And what is harm on a different time frame? It's all this is important. It's like you can, for example, there's some quote unquote easy things, like, okay, don't kill people, don't maim people. That's quote unquote easy, but there are things that might be unpleasant, but are good in the long term.
Is it?
So yeah.
Like, what do you mean by that, for example?
Like for example, sometimes you want someone to tell you the truth, even if it's unpleasant.
Oh, okay. Like constructive criticism, something like that.
Yeah, exactly. Criticism. So if we have LLMs that tend to agree with you and say yes all the time, that's not necessarily in your best advantage. There's deep questions about what it means actually to like questions about what's good and what is good and bad, what is justice. Mm-hmm. Like these questions need to be addressed before we can regulate that, because this is I think where the discussion should be. Like we should.
Yeah, these questions were being looked at by the community between 2018 until end of 2022 privately. So that means that we had these LLMs and we knew that we had LMs, language models, and we were able to work on them and work on the biases and detect them and try to fix them and things like that. At that time, we did not we could see some utility, but we did not think to release it to the general public until OpenAI did it. Yes. So once that gate was open, it's very difficult to close it again and say oh, we need to do more research before y'all can use it again. So that's very difficult to do. You can't close back the door once you open it, or
the door is open.
Yeah, so we can't actually do anything about it. At this point, you can't say, okay, well, we'll just take it back, or forget about using this model. We have to do more research about it, and it'll take years.
Yeah, nor do I think that we should take it back. LLMs are, everybody's talking about LLMs. LLMs is basically for the general public, AI means LLMs, basically.
Yes. Yeah.
But there are other types of AI models that might be even more problematic in the long run than LLMs. That convolutional neural networks are, to me, they're the top of the list.
Because of like image generation?
No, because of all the things that you can do with images that you don't necessarily want people to be doing.
Yeah. Yeah, like that, but those are being used, like they're open source, and lots of people are like putting faces where they don't belong and things like that.
Yeah, it's a generation, but then also like all the things that you might be doing, like in the service sector, might be doing with facial recognition, for example.
Yes,
or human recognition, or this. I think like if you look at the potential applications, I think convolutional neural networks might be the thing that causes more problems in the long run than large language models. That's my opinion.
Interesting to see.
Yeah, I might be wrong. I might be wrong, and because also they're easier to use, easier to train. They don't require that much compute power, and you can do a lot with that. You don't do the same things, but you can do a lot with this type of neural networks. Yeah, all that is but again, it has to be at a certain point. We need to have a philosophical discussion. We need to go back to ancient Greece.
Yes,
yeah,
differentiate good from bad.
Exactly. Sit around, I don't know, fire and just talk about what it means to be human.
Exactly.
So you can make the regulations.
Yeah, exactly.
Yeah. Do you want to add anything? I think this is a good place this could be a good place to stop, I think.
Yeah, that sounds great.
Yeah.
Thanks for the discussion. It was very interesting, and for the opportunity to talk about this paper, which is like raises a lot of meta questions.
Ew.
I hope that like the audience like will enjoy like the discussion around it as well.
I did.
That's great to hear. Yeah. Thanks, Tyler, for inviting.
Thank you, Khalil. Thank you. It was a great time. Thanks a lot.
Yeah. Take care.